Hey everyone, Professor Baldwin here, and today we're going to learn how to solve polynomial inequalities and rational inequalities, which means we're taking our inequality game up a notch. In order to solve a polynomial inequality, we're going to follow these 4 steps, and I'm going to guide you through those with an example. First step is to find an equivalent inequality with 0 on one side. What that means is we need to subtract x and add 2 to both sides. Doing that will give us x squared minus 2x minus 3 is greater than or equal to 0. Now we have an inequality with 0 on one side. Next is to change that inequality to an equal sign. That'll be x squared minus 2x minus 3 equals 0. We need to now solve this, and because it's a polynomial, we're going to factor it in order to solve it. This polynomial has a leading coefficient of 1, which means each of our binomials will just start with an x. And we're looking for the two numbers that multiply to -3 and add to -2. That would be -3 and a positive 1. Now, using that zero product property, we solve this and we get x equals 3 and x equals -1. Now, we're not done. These values are what we call critical values. And if we put them on a number line, we have -1 and we have 3. Notice that it broke this number line up into 3 chunks. These are called our intervals. And we're going to pick a test value in each of these intervals to see what this polynomial is doing in each interval. In the first interval, how about we pick a test number of -2. So with a test value of -2, we're going to find the value of -2 squared minus 2 times -2 minus 3. Or 4 plus 4 minus 3, that's 5. We don't care about the value, we care is it positive or negative. Well, here it's positive. Now let's move on to the next interval. Well, the best test number in here would be 0. And therefore we're solving 0 squared minus 2 times 0 minus 3, which is 0 minus 0 minus 3, or -3. So we have a negative in this interval. And then we need a test value in our last interval. How about the value 4? That would give us 4 squared minus 2 times 4 minus 3, or 16 minus 8 minus 3, and that's 5. This is also positive. Now we go back to our inequality. We are looking for values that are greater than or equal to 0. So that would be positive value. So what intervals are we positive? Well, this interval and this interval. Notice that we have this equal sign. So we're looking for greater than or equal to. That means we're going to include these endpoints of our interval. So from left to right, our first interval is going to be from -infinity through -1. And we're going to have a bracket because of that equal sign. We're including the -1. It'll actually be a value of 0 there. Or it's the interval from 3 to +infinity. See, that wasn't too bad. Now let's look at an example of a rational inequality. Remember that a rational expression is one that's in fraction form. And with this example, we're going to follow these 5 steps. So just like the polynomial inequality, we first need to find an equivalent inequality with 0 on one side. So we'll subtract x over x plus 1 from both sides to get 5x over 7x minus 2 minus x over x plus 1. And that's greater than 0. Now our next step is to change the inequality to equal and solve. That would be 5x over 7x minus 2 minus x over x plus 1 equals 0. Well, since we have fractions, we want to find the LCD, which is going to be both of those numerators. Sorry, both of those denominators, 7x minus 2 times x plus 1. And we'll multiply each term by that LCD. And notice that on the right we have 0, so that'll just stay 0. And we have our denominators, 7x minus 2 and x plus 1. Now, we want to simplify. The first term, the 7x minus 2 simplifies out as 1, and in the second term, the x plus 1 simplifies out as 1. So we're left with a 5x times x plus 1 minus an x times 7x minus 2 equals 0. We got to keep on going so we can simplify this, because remember, we're trying to solve it. Distributing 5x, we get 5x squared plus 5x. Now we need to distribute negative x, so we get negative 7x squared plus 2x equals 0. And we want to combine our like terms. That'll get us to negative 2x squared plus 7x equals 0. We're getting so much closer. Now, combined our like terms, let's factor out the GCF of x, and that gives us negative 2x plus 7. Now we can apply that zero product property, which tells us that x equals 0 and negative 2x plus 7 equals 0. Solving that, we get x equals 7 halves. So these first two values that we found, let me circle them. These are two of our critical values. Now, step 3 is asking us to find the other critical values. So those are whenever this rational expression is undefined. So undefined is whenever a denominator is 0, or 7x minus 2, our first denominator, equals 0, or the denominator x plus 1 equals 0. The first gives us a value of x equals 2/7, and the second gives us a value of x equals negative 1. These are our other two critical values. For this problem, we have 4 critical values. Let's make that number line and put those critical values on there. We start with negative 1. I'm going to put a star next to negative 1 because it makes the denominator 0. We cannot include it in our solution. Next would be a value of 0. Then we have the value of 2/7. Again, I'm going to put a star next to it because it's the other value that gives us a denominator of 0 or undefined. And our last is 7 halves. Now, notice we have 1, 2, 3, 4, 5 intervals that we have to check. So we need to find test values in each of these intervals. I've showed you how to use a test value, so I'm going to tell you the test value and give you whether it's positive or negative, and you can check for yourself. So I use the test value of negative 2 in this first interval, and I get that that value is negative. In the second interval, I'm going to use a test value of negative 1/2, and that interval ends up being positive. The next interval, I used a value of 1/4, and that was negative. Remember, you can use your calculator to check these test values, and you're really just looking for, do you get a positive or a negative value? The fourth interval here, I used a test value of 1, and that was once again positive. And the very last interval, I used 4 for my test value, and that was negative. Remember that our inequality was greater than 0. So we're looking for any interval that was greater than 0 or positive. That would be right here and right here. So what are those intervals? That first interval is from -1 through 0, and the second interval is from 2/7 through 7/2. See how helpful that number line is? And make it large if you need to, so you have plenty of room. Not too bad. Let's look at an application example, a word problem. We're given a function that represents the total profit, and we're asked to find the values of x for which the profit occurs and when losses occur. Well, what we need to do is just solve that polynomial, get our critical values, and then use some test values. So we're going to solve this equal to 0. Notice we have a GCF of -3. We're going to factor that out first. That gives us -210x plus 2,000 equals 0. Now we can ignore this -3 because -3 equals 0, not possible. We need to factor x squared minus 210x plus 2,000. Well, factor smart with this. Leading coefficient is 1, so our first terms are going to be x. Now 2,000. 2,000 is what? 20 times 100, 200 times 10. There we go. 200 times 10. 200 plus 10 is 210, and 200 times 10 is 2,000, and they both need to be negative. Solving that, we get our critical values of x equals 200 and x equals 10. We need that number line. It's super helpful. So draw your number line, put in your two critical values, 10 and 200. You're going to find some test values. So for 10, less than 10, let's pick a test value of 0. That ends up being negative. We don't want a value too high. If you put in a value of 11, it's a little bit easier of math, and you're going to get a positive value. And if we pick something larger than 200, such as 201, you're going to get a negative again. So part A wants to know the values for which we have a profit. Well, profit would be greater than 0. When is it greater than 0? That's in the range from 10 to 200. And part B wants to know when there are losses. That would be a negative value, less than 0. That's going to be 2 intervals. Be careful though, what is our first interval going to be? It's not going to be negative infinity because we're talking about producing something, and the least that you could produce would be 0. So it's going to go from 0 to 10, and then it'll go from 200 to what value? Is infinity possible? Of course, infinity. So we were able to solve this word problem and determine which values they'll occur losses and when they'll see profits. I know this was a bit quick and there are lots of steps. I promise practice will make progress. If you have a question or you come across a problem you want help with, leave it in the comments and I'll make a video for you.